Hello everyone, welcome to Arduino Made Easy Part 3. In this video, we're going to be looking at analog reads. To get started, you'll need one Arduino Uno, one breadboard, one potentiometer, one LED, some jumper cables, and one light dependent resistor or LDR. Okay, so in this tutorial, we're going to be looking at how we can use analog reads to control output devices. So analog reads can be anything from your humidity sensor to your pH sensor to your temperature sensor, essentially any sensor that you need a range for. The reason why we can't use digital pins is because this one, the Arduino, can record value from 0 to 5 volts, whereas your digital inputs can either be 1 or 0. So not a lot of sensors does 1 or 0. If it does 1 or 0, we most of the time just call it a switch. So we'll start this code by initializing an analog pin. So we have to create a variable. We say variable analog pin, and we call that A0. You can see on your Arduino board, you have analog pins on your right side at the bottom from A0 to A5. So you have 6 analog pins. We choose to use A0 in this case. Now remember, for digital pins, we have to initialize them, saying pin mode and then the pin number, whether it's high, whether it's an output or an input. For analog input pins are inputs. So the Arduino already knows that. So we don't need to tell the Arduino again. However, what we need to do for debugging is we need to have serial print serial.begin 9600. That's the baud rate. Just add this. I think it looks a bit nicer. And we'll put a variable here because when a variable is created inside a loop, in this case the void loop, that makes it local, which means it does not exist anywhere else. And we don't really need it to exist anywhere else compared to the analog pin, which is a global. This variable, we need it in the whole program. That's why it's called a global. Whereas this variable we just created, which is analog value, this one only exists in the void loop, which keeps looping all the time. So analog value, what we want to do, we want to assign it to analog read our analog pin, which is A0. And now we want to serial print analog value so we can see the value on our screen. We add a delay of, let's say, 100 milliseconds just for us to see the value on the screen. So now if I flash my code, it's compiling, uploading, there we go. So now if I open the serial monitor, you should see variable. You see the pin is floating, so it's anything at the moment, it's all over the place. However, remember how I said it can read from 0 to 5 volts? If I connect it to 0, which is ground, I get 0. But if I connect it to 5, I should get 1023 as I get. But this value is not very useful because what we want to read is voltage. So we will create another variable, another integer, and we'll call it voltage, just to keep things simple. It's equal to map. We call a function named map, which will map from every value from 0 to 23 from 0 to 5. So map, what do we want to map? We want to map the variable, which is analog value. What is the range of the input? 0 to 1023, and 0 will be mapped to 0. However, 1023 will map to 5 volts. So that's literally one line, and the Arduino does all the calculation. Now let's check if that works. Okay, so let's put analog value. This time we'll print voltage. Voltage. Okay, we'll flash the code again. It's floating. There you go. It's floating the pin because nothing is connected to it. But if I were to connect it to ground, it's reading 0 volts. And if I connect it to 5 volts, it reads 5 volts. And the pin next to it will read 3.3 volts, but because it's an integer, we'll only read 3 volts. There you go. And let me know in the comment section below if you know why it doesn't read 3.3 and reads 3 volts. So now we want to use the rheostat so we can see some actual input. We can give it some more predictable input. So first, we'll connect our potentiometer to our breadboard. One of the pins, either left or right, will go to ground. And the middle one will have to go to our analog 0 pin, because that's the value we have to read. And the other one left will go to 5 volts if you connected the first one to ground, and vice versa. So now you see the value stopped floating as soon as I connected that. But what does this do? See, if I turn it maximum, it's 5 volts. If I turn it low, it's 3, now it's 2, and it's 1, and it's 0. This is how your knobs work, whether you want to control the volume of your speaker, the speed of your fan, or in some industrial application, whether you want to set points. Yeah, these are all, that's the basic mechanism that works behind a knob or a dial. Now, how do we use that to control something? We know the voltage. So we say if, let's say, voltage is greater than 3 volts, okay? So what we want to do, we want to digital write LED high. Now notice this value, this variable is not initialized. So I have to go up here, I have to write integer LED. Let's say we're going to use pin 9. And here we go, pin mode, to tell the MCU that pin 9, which is LED, is an output. Okay, so let's do that actually first. So I'll flash my code, and while the code is flashing, I will connect an LED to the breadboard with one of the long side always goes to the positive, and the small side, the shorter side, always goes to ground. So shorter side will go to ground, and the longer side will go to pin 9. There we go. Now, if we increase our value over 3, the LED will go on as it goes. So at 4, it's still on. At 3, it's off. Well, the reason why it does not turn off is because we never wrote a code that actually makes it turn off. So how do we fix that? So if the voltage is more than 3, destroy the pin high, else, meaning that if it's less or equal to 3, then what do we want to do? We want to digital write LED low. Now let's see how this turns out. There you go. So the pin is off now, and if I increase my reading, so 1, 2, 3, it's off. However, if I increase to 4, it's on. And same if I go down to 3, it turned off. I go back to 4, and then eventually 5 is still on. Now that's a basic application so we can control something, but let's try to use a more of a sensor rather than a human input. So what we will do, I'll unplug the MCU, and we shall replace our potentiometer with a resistor and a photoresistor, which is a light dependent resistor, which is a fancy way of saying the resistance varies as the light intensity changes. So I'll connect one side, which is the ending side of the photoresistor, to ground, and the start of the resistor to 5 volts. And when the node at which they join, which is one pin of the resistor and one pin of the light dependent resistor, will go to analog 0. Now I don't have to make any modification on the code because I'm still reading from A0. So I'll wait for the board to connect. It should happen anytime soon now. There you go. See, the value is 3. So my light intensity is 3 because that's probably my room light. But what if I increase the light, if I turn on my flashlight and increase the light intensity on the sensor? Let's see if that changes anything. See, now it's 2. What if I put my finger on it? It goes to 4. 3, 4. Now, let's say there's lights here now. And a basic application, I'm going to show you rather than explain it to you, is there's lights now. And the way your street lighting works is either you have a panel, but let's assume you don't have a panel. It's completely autonomous. So if you flick off your light, see that turns on. And if I turn on back my light, it will take some time, but as soon as my lights turn on completely, it should go off. But you see, it's still 4. If I give it some assistance, and let's say I increase my flashlight on there, it turns off. And if I increase it again, let's try that again. So light off, light on. And that's all. I hope you really like this video. I know it's a bit long, but let me know in the comment section how you guys feel about this type of videos. And let me know if you feel there's other applications for this. I would really want to know what you guys think about these types of sensors. I think they're quite popular in the industry. But yeah, if you haven't watched my other videos, please watch them. And please, if you like my content, please like, comment, and subscribe. It just helps with the algorithm. And I'll see you guys in the next one.